Okay, so in today's video, I'm going to be showing you how to make power functions extension cables. We're also going to be making a few specialized adapters that you'll need if you want to use IR receivers or servo motors, because they are wired a little bit differently. One thing to take note of, this is an official Lego extension cable, and then it had a 9-volt adapter on the bottom. I would love to find this piece online, but I haven't been able to find it. But there's going to be a lot of info here that is going to be very important, so you don't damage anything, things that you might not think of but are extremely important. So if you leave a comment asking a question and I say it's covered in the video, it's going to be covered in the video. So let's take this for example. We've got this studs up. We're going to pull straight out. The other end is studs down, and that's because this leftmost contact here is ground and the top right here is 9 volts, and that's always going to be a steady 9-volt current, and that's used for things like the IR receiver, because these two inner contacts, C1 and C2, are going to be powering your motors in maybe forward or reverse direction, and lower voltages, so that's always going to be changing. But these two outer contacts are going to be constant, because you wouldn't want to run this off 3 volts in reverse direction. It's just not going to work. So that's why they have a 4-wire system, and that's something we're going to have to keep in mind through this entire process. So this is one that I made, and it's a decent length. It's much longer than you'd be able to get from Lego, and I have even longer than this. And of course, if I were to lay this out, these are going to be reversed like that. It's kind of the same as, say, an NXT cable. If you pull it straight and look at it, they're actually reversed. So that's what keeps your polarity right and everything like that. And of course, for our wire, I was very happy to find that my BNTechGo wire, 24 gauge, it's silicone flexible insulation. It works extremely well for not only these, but for the 9-volt connectors. That's what I bought this wire for, and I was very happy to find that it works seamlessly with making your own power functions cables. So I will link these in the description below. This is a 25-foot roll. I believe I paid about 20, or I mean this one I paid more for, but not long after the video, the price went down a good bit. Maybe I should have done an affiliate link. So this is $20 right now. That's 25 foot, and if you're making 9-volt cables, you're getting 75 foot because it's actually 6 conductor wire. So you can pull these apart and get more out of them. This is a 50-foot roll. These are what I've been ordering lately, so I have a total of, I bought 1 of these and then 3 of these already. Pretty much anytime I have my Amazon Prime going, I will order 1 of these. So this is 50 foot. So for 9-volt connectors, you can get 150 feet, or 100 foot of power functions, and then another 50 foot of 9-volt. So this is the 6 conductor wire. And if you'll look, it looks fairly small in the gauge, but you'd be surprised. There are plenty of these cables going around online, and I've already taken the end off of this one. You probably can't even see the wires there. I don't know how well it's going to show up on the camera. It actually, yeah, well, this is much better than these, and I'll show you later some more reasons why this just isn't great. I think the way it's cut, maybe it looks a little different, but we will get into that. So first off, let's go ahead and cut some of this wire, and we'll make our first cable. And we'll be using, I found these ends on AliExpress. You may be able to find them other places. I started with these cheap extensions, popping these connectors apart. The problem is these 8 contacts, blade contacts, fall out as soon as you take this apart, and they go everywhere, and you'll have to look on the floor for them. It's a nightmare. Luckily, these are put into place fairly well. So you don't have to worry about these flying all over the place. I would inspect them because I did have one of these where one of the pins was just pushed in a little bit and it just wasn't quite right. And so after I made a cable, I had to pop it apart and fix that. So we'll take two of the bottom pieces, two of the top pieces, and I'm just going to cut, I don't know, I'm just a cable like that. Set this to the side. So now we have this piece of 6 conductor wire, and I'm going to pull off the two on the end here that have the white dotted or dashed line through it, just because I don't know, I can be a stickler for aesthetics sometimes. So we can set this to the side. I have lots of scrap pieces like this that I will use, especially if it's going to be underneath plates. If it's going to be hidden, I'm not worried about that. So let's pull this, and this wire, if you just kind of pull it straight, it tends to keep its shape pretty well. So it doesn't stay all bent. It's very flexible. It's a very good wire. So like I said, I always try to inspect these and make sure everything looks good. That looks fine. Yeah, this one's pushed in a little bit, so which one is that? That's that one. Okay, that looks better already. What I've been doing is starting with the top part with the studs, and this wire is a slightly oversized, but again, I like that. I like being able to get a decent amount of current through these. And we're just going to place it in there, just like that. You don't have to go all the way to the end, but you do want to make sure that all your pins are going to get contact. So I mean, it's mostly up in the front here. So we're just going to center it, and like that, and you just want to push down enough to get it started, because once you sandwich the two pieces together, it will kind of bite into the wire on its own. So that's these blades digging in, and again, that's why the right wire is so important, because the blades have to be able to pierce right through to make contact. And I'm just gonna snap it together. And it usually doesn't go all the way in, so I just kind of go around on each little clip here, and push it together. Just like that. So now I've just got, these pieces are great if you want to attach power functions very easily. And one end at a time, we're going to take a multimeter and test. All right. So we're just doing a simple continuity test. Start with that pin. And I usually test next to it to make sure you don't have a short, which I really haven't had many. Perfect. And again, you can do a quick sanity check and make sure the ones next to each other aren't shorting out. Perfect. Again, we're going to take it and pull it out. And this one's going to go upside down. So that's how we're doing it, like that. That is extremely important. Unless, if you're just running a motor off of it, it'll be fine. But you might as well make these correctly to begin with. And then if you get more parts later on, you want to start doing the IR receivers, things like that, it is going to be extremely important for these to be flipped. So that's that. Perfect. Now, I usually test the top and bottom because of the way these are. You know, to make sure it gets into both contacts. So I'm just going to use a plate here to keep them in place. Perfect. And I'm going to go one step further. I built a wire tester. And this functions just like a, if you've ever made your own network cables, it works basically in the same way. Basically, we're using ground on this leftmost pin, and then the other three contacts are going to the outputs here. And you can see these 9-volt connectors only have one wire coming out on each one. So I'm actually grabbing ground from the sensor port up here. And then these break out to each of the lamps here. And this is an electric plate in the bottom. And this actually is removable. So if you wanted to, if you already have it laid across your layout or something, and you want to test a long cable, that's why that's removable. Again, just like a network tester. So if I turn it on, you can see the little arrows on the bottom there. It's going through each one for 1 second. So this wire is good. And if it wasn't good, I would either have 2 lights lighting up at once, none of them lighting up, or anything besides this means something's wrong. But again, I've had very, very good luck with these connectors, this wire. It just works. Like I said, I've had maybe one issue and was able to remedy it very quickly. So that's all you need to know to make just extender cables. You know, again, make sure they're reversed like that, and make sure you're using good wire, which again, this stuff is great. So now let's move on to some adapters. Okay, so now we're going to be making an adapter from 9-volt to power functions. There are many reasons you would want to do this. For me, I tend to use the 9-volt regulators quite a lot. I've even upgraded these with upgraded components inside. 2 power IR receivers to control servo motors, all that kind of stuff. So this is actually the shortest one I've made, and it's literally that big. And it does need to be straight through for me. I always turn the dial to the right. I always connect the connector with the wire going that way. And in that case, it needs to go straight through to the connector, and it will be able to power a IR receiver or servo motor in the correct polarity. That is extremely important. And that's why I have a standard when I make these. So that's why when I put it on top, it twists a little bit. So this is just a cute little guy that I use quite a bit for for this. And I actually thought about trying to take this out and put a power functions connector in there, but the more I looked at it, it just wasn't going to work. If you go that way, the wire is going to hit on that, and if you go that way, you're just going to have to do a good bit of cutting and hacking. I mean, I might be able to, if I shave this off there, it might be able to fit into that little recess there, but we're not going to worry with it today. So this is the connector we're going to make, and I'm going to start with the 9-volt end, and I have an entire video on doing the 9-volt ends and things you need to know with that. So I'm not going to go into great detail here. I want to keep this video not too long. So I've already straightened out the contacts inside there. We're just going to pop it on like that. And that should be good. We can either use a multimeter to make sure we've done this correctly, or I've purpose built my own wire tester. I may eventually do a version 2 that's a little easier to build, and then I will do instructions for it. So this first one tests if there's a short, and you can see if I were to short it out, the red light lights up. So we don't have a short, we're good. And then these test continuity through it. So I'm going to test one wire, test the other wire, so that one's good. And then test the other wire on this side. And we've got continuity. So we know this is a good connector. So just like that. And we need to leave a good bit to work with. Okay, that looks good. We're going to carefully pull these wires apart and fold it over. I feel like this is much easier the last one I made. And you want to go all the way to the end here. Oh man. Okay, so that one looks good. And of course it just came out. Okay, so once you get it in place like this, you know, it's going to be a little bit tricky to get that. But once you do, just go right in with the connector. Okay, so now we have our connector, and we're going to do a test. I have, of course, haven't built a tester for this part. So the way we've done it, one pin should go to 2 and not the others, and the other pin should go to the other 2 and of course not the others. And because these connectors are connected inside, you don't have to worry about testing the bottom of this one, but I always test both sides just to be sure. Just because, you know, you've got eight metal pieces in here, so they all have to make contact. So that was a bit of trouble to get it in position. You could just put a 4-wire inside of here and then do the rest of the work on the outside and just like solder these together. I always do, you know, the inner pair You know, I just always go to the next pin over, and that fits my standard for making sure that the polarity is correct. So now I'm going to show some use cases for these, and you know why I go through the trouble of making them like I do, because the official Lego wires, while the top 4 connectors are all connected, the 9-volt connectors are only going to the control wires, which are the inner pair C1 and C2. And you know, they had a good reason for it. They don't want you to damage your stuff. So, all right, let's take a look at some use cases. Okay, so this is the use case that made me make my own cables for the first time. These, again, are the cheap extensions you can find on AliExpress, eBay, Amazon, all over the place. And that's as long as they are, so if you need a long one, you have to hook lots of them together. So this is 5 of them in series. And I'll show you what happens when I try to use them with servo motors. Okay, so you can see we've got power. It's lit up. It's doing better now. Of course it is when the camera's rolling. I just tested this. These would get stuck halfway. They wouldn't return to center. And you can just tell they're struggling a little more than they should. And, you know, it's not just the gauge of the wire inside of here. It's the amount of connectors you're having to go through. You're introducing a lot of resistance. But this did give me major problems. So I'm going to take all these out. Now this is an extension I made, which is actually longer than all those cables together. And this is made with a good wire. And I'll just keep it bundled up. You hear that? That is a huge difference. Especially if you're doing 2 at a time. So this works perfectly. As you can see, it makes a big difference. And to power these, you only need the outer 2 wires, the 0 and 9 volts. But let's say you want to do let's say I want to power one of these from a switch like this, and I have shown this before, but you have to have power on all 4 wires for this to work, because it's actually using the inner pair to kind of give a signal to tell it which way to go. So that's extremely important. That's why I make these the way I do, because the official cable won't do any of the things we've seen here. It will only connect to a motor and power it. So that's what I've got so far. I hope this is helpful for some people out there, maybe build crazy things like I do and want to make your own connectors. Again, these are on AliExpress. I guess I'll link to them. I always hate to link to stuff like, you don't know if the links are going to be there later on, or how the quality is going to be over time. You may get a bad batch. It's one of those things when you're buying cheap stuff online. But again, there's nowhere else you can get them from unless you want to take your official, Lego motors and start ripping connectors off. You probably don't want to do that. So I hope you found this helpful. If you have any questions that aren't addressed in the video, go ahead and post them below. And thanks for watching. We'll see you later.